Infosyte has been one of the top ICT services and training provider companies in Malaysia. Infosyte office is located at Sertia Walk in Puchong. Our location is easily accessible and strategically located within a walking distance of LRT and bus stations. Our vision is to inspire excellence through our sworn commitment to quality, innovation, and efficiency. We ensure excellence and experience in our trainers to strive for our goal of providing only the highest quality of services to our students. We provide a wide variety of training programs which include technical training and soft skills training, both indoor and outdoor training. Our spacious, comfortable, and affordable training rooms are available for rental with high-speed internet. With our experiences in delivering ICT expertise to thousands of clients all over the world. Infosyte works with partners such as Huawei, Microsoft, Veeam, Linux Professional Institute, and CompTIA. We have many happy and satisfied customers and students all around the world, places like Canada, Poland, Australia, South Africa, Nigeria, Japan, Singapore, Norway, Hong Kong, Tunisia, Botswana, Kenya, Thailand, Indonesia, and many more. Infosyte, your trusted professional training experts.
All right, a very good afternoon, everyone. Welcome back to Infosyte's monthly live webinar here. Hopefully, how's everyone doing here? Hopefully, everyone is doing good. All right, so I do see some familiar names and not your faces, of course, but some familiar names in the attendees here. So welcome back. I think some of you have been following us for quite some time already. So for today's session here, we have a very, very interesting topic here. We're going to talk about, of course, our title, as you guys have seen, we're going to talk about Aiyaaa. Everyone should know about AI in 2022. All right, AI, I'll let our speaker explain more about AI later, which stands for Artificial Intelligence. We'll see what we can do with AI technologies and how AI has impacted our technology or our lives as well. That will be covered by Gabby later. But just a quick introduction about Gabby herself as well. So our speaker here for today, of course, is Gabby Liao. She's one of Infosyte's in-house trainer who specializes in AI technology. She also does cloud services training as well. So do expect quite a lot from her. There's going to be quite a lot that we'll be going through. So do stay with us. We're going to explain about what is AI technology. Of course, we have our usual Q&A session as well, where there will be prizes to be won. And do stay tuned all the way towards the end, where we do have some exciting promotions that we will be sharing with everyone as well. All right, so without further ado, I'll pass the floor to Gabby, and she'll bring us through our session today regarding AI. Gabby, over to you.
Thank you, Liu. Thank you, Liu. And yeah, good afternoon, everyone. Good to see you here. And so I will be the speaker of the day. So my name is Gabby. You can just call me Gabby or Gab. I'm fine with both. So for today's agenda, you will see that we'll talk about some AI. And for today's sessions, we'll talk about some daily examples of AI applications. You know, sometimes, you know, we use AI, but we don't know we actually are using the AI. So in this, the first part of our session, we'll talk about some example. And then we'll talk about some definition of artificial intelligence, because now when people ask you what is AI, sometimes there can be a lot different kind of the definitions coming up. You know, from different people, we might have different definitions, you know, about this AI. So later on, after we have looked into some example, we'll also talk about the definition of AI, especially like, you know, what it can do, what we can use, you know, where we can apply this AI. So we will talk about that in our second part of the session. And at the end, we'll talk about the process flow of constructing the AI model. If let's say you want to come up with your AI model to work for some tasks, you know, so what you should start with. Okay, we have to start with the data collection and what is the next step and so on. So we'll talk about the entire process flow of constructing the AI model. All right, and for your information, at the end of our session here, I will also be doing some simple demo to you. So to show you by using the Python, how can we simply construct a small model, a small simple, deep neural network model that can help us to detect the images. Okay, so that will be the agenda of our today's session. All right, so now without further ado, let's look into some example of AI application. So you can see that one of the daily example is the personalized recommendations. So I believe that every one of us go to the online shopping platform, right? So for example, like the one that you can see from the slide here, this is this is something that you will see when you go into the Shopee, the online shopping platform. So they will recommend you some product that you might like. Or maybe when the time you go to the Netflix, they will also recommend you some movies that you might also prefer to watch. And maybe sometimes when you go into the Facebook, they will also recommend you some people you may know. So all these are the examples of AI application, because all these, they are running AI. The AI is trying to look into your previous history, of searching, of browsing the product. So by using this previous history, previous information of yours, they'll be able to provide you with some recommendations that you might like. Okay, so this is one of the example of AI applications in our daily. All right. And other than this recommendation system, we have also the autonomous driving. So I believe that everyone heard about the autonomous driving before. So you can see that with this autonomous driving system here, we can have the car, we can have the vehicles to drive itself on the road, right? So with the detectors like the smart cameras, with this radar, with the ultrasound sensor, all these detectors will be embedded around the car. So the car will be able to perceive the surrounding environment through this detector. So all of this detector here will basically help the car to collect data regarding the surrounding environment, the condition. And the data will then be fed to the processor. The processor in the car will make use of the AI model to calculate the result based on the data. All right, so to tell the vehicle control system whether that should remain the speed of the car or to slow down the car, to stop, to turn left or to turn right. Okay? So the behavior of the car itself will be determined by the result from the model prediction. All right, so for example here, if let's say there's one of the smart cameras here collected the image that has a person trying to cross the road at a distance of around 10 meters ahead of the car. So what will happen is that the image will be sent to the AI model, and the AI model will be able to detect the person in the image. And once the person is detected, so the AI model will return a result that can make the car to slow down and ultimately stop before it hit that person. All right, so that will be basically AI in the autonomous driving. Okay, and other than this autonomous driving, you will also see that the other example here is the impersonation. So I believe that everyone's seen this before. You know, when people can actually replace the person's face with another person's face. Or maybe they can put the expression of a person onto the other person's face. So this technique is actually called as a deepfake. Deepfake, all right? So now let me show you a video on YouTube to look at how amazing this technique is to fool the people, all right? So let me show you this video.
Tom Cruise has become a viral hit on TikTok, or has he?
That's freaky, man. We're living in freaky times right now. Looks exactly like Tom Cruise.
In this reel, you're going to see my amigo, Chris Umi. He's going to introduce to you the wonderful world of deepfakes, how AI and VFX are unlocking the future of our imagination.
I made the Tom Cruise deepfake, and it was one of the biggest viral deepfake videos on the internet ever. I'm Chris, and I'm a VFX and AI artist. I'm trained as a cameraman. I've been doing VFX for about 8 years. The first time I heard about deepfakes is the end of 2018. It was on a new channel where they were talking about people misusing the technology in pornographic videos. And that made me realize there were a lot of creative possibilities. A deepfake is a video where someone's face has been changed into another. So, for example, in the videos I make with Miles Fisher, you don't see Miles Fisher's face, no, you see Tom Cruise's face. I just overlaid it on top of Miles.
With your help in 2020, together, we'll dominate the ballot box. This is no stunt.
The way I train a deepfake is where I tell a computer model to start training on thousands of images of a certain character. In my case, it's Tom Cruise. Thousands of images, all his expressions, all his angles. So in the end, I have like one big model, and it's like one big Tom Cruise model. All of Tom Cruise's emotion is in this model.
Tom Cruise.
All right. Yeah. So very interesting, right? Yeah. So basically, you can see this deepfake video. The deepfake technique here can be used in different kind of scenario. So some people make use of this technique to do something bad, but sometimes when you know how to use this technique, you can even use it to enrich, some video to make it, more interesting and so on. So this is one of the example as well of AI in our, in our daily. And so maybe some of you might wonder, how can they make this, make this kind of the deepfake video? So yeah, basically the working principle behind this deepfake technique is actually very simple. So if you look into the, the working principle, they'll be using this AI algorithm called as the autoencoder. So the autoencoder is the algorithm that consists of two parts. One is the encoder, another is the decoder. So encoder plus with the decoder, these two make up the autoencoder. It's a kind of the algorithm. All right. So with this algorithm, you will see that if we want to, let's say today, you want to swap the face of Tom Cruise and Brad Pitt. So if let's say this is what you want to do. So it is very simple. What you need is just two autoencoder here. So you feed the image of the person who you want to swap their face into the encoder. Like the Tom Cruise face, the images here, you put into the encoder. Same go for the Brad Pitt. You feed these images into the encoder. And what the encoder algorithms will do is that it will try to summarize the feature of that person's face. Okay? It will try to summarize, okay, and make it into latent space. So the latent space produced by the encoder will consist of all the key features of that person, like how the nose looks like, how their mouth looks like, what is the expression details, so all these key features of that person will be summarized into the latent space. And same go for the one of Brad Pitt. So this latent space of Brad Pitt here will have all the information about Brad Pitt's features on the face. Okay, so this is what the encoder will do. It will summarize the features. So after we got this latent space, so what we can do the next is that, okay, assume that now you want to create an image of Tom Cruise, but with the Brad Pitt feature on Tom Cruise's face. So you just need to tag the Brad Pitt features from the latent space, all right, fit into the decoder of Tom Cruise. You fit these features into the decoder, and the decoder here will be using the feature of Brad Pitt to reconstruct the Tom Cruise face. So the product of the decoder will be the Tom Cruise face, but with the Brad Pitt feature. So if you want to do in the opposite, you want to create the Brad Pitt face, but with the Tom Cruise feature, you can also do the same thing. Taking the feature from Tom Cruise latent space, it put into the decoder, and you will be able to get the reconstructed Brad Pitt face with the Tom Cruise feature. All right, so this is how they work in the back. So yeah, by using the autoencoder algorithms, all right? And for some developer, they're not just using one AI algorithm, but they'll be using the other algorithms called as a GAN, Generative Adversarial Network, a very popular deep neural network that can be very good at generating the images. So they are combining these two AI algorithms together so that the GAN here will be able to help the autoencoder to further enhance the result. Okay, so to make the result more realistic. So this is how they do in the back. All right. So this is the example number 3, auto encoder. You know, the deep fact, the technology. All right. Okay. So after we have talked about all this example here, so we can come back to our definitions. Okay? The definition of AI. So the definition of AI is actually very, very, very simple. AI is a technology to simulate human intelligence into machine. That's simple. With the AI technology, we are trying to make the machine to work, to behave similar to like human, or sometimes be even better than human. That is what we want to achieve. We want the machine to have the human intelligence. So we are simulating the human intelligence into the machine. For example, just now, when we talk about the autonomous driving, and the car itself can see the road, can drive on the road itself, just like how the human can drive. So to enable the autonomous driving, we can simulate the human visual intelligence into the machine, which is our vehicle, our car, so that our car can see the things that is appearing on the road, just like how human can see. Or for another example, if you look into the Siri, you know, Apple Siri, Microsoft Cortana, or maybe some virtual assistant. These are some examples of the system of AI, which we have simulated the human verbal intelligence into it. Okay, so that it can talk back to you, it can understand your verbal instructions, it can understand your language, just like how human can do. All right, so depending on our goal, our target, we can design an AI system with different or multiple intelligence simulated into it. So to perform some tasks, just like how human can do. Or as I mentioned, or sometimes it can be better than how human can perform. All right, so that will be the definitions of AI. We are trying to simulate human intelligence into machine. Okay. So these are the 4 very important elements in AI. So when we want to construct AI system, we want to use this AI solution. So these 4 elements we must know, okay? And we must get them as well, because without any one of these elements, you can't have a good AI. So first is a scenario, where the scenario is something that you have to determine first before you can know what kind of the AI system you have to construct. Okay, the scenario is like, okay, let's say today my company wants to come up with this electronic attendance system. Okay, so let's say this is a scenario. So what I'm going to do now is that I might need to come up with this facial recognition system, so that this facial recognition AI model can help with the electronic attendance system. Okay, so this is your scenario. So based on the scenario, you will know what kind of AI you want to build. And based on the scenario, you will try to collect the data that is relevant to your AI prediction. So let's say you want to build this model for facial recognition. So the data that you're going to collect will be the image data of your colleagues, you know, of your boss. So you have to collect the relevant data. So then we'll be using this data to train our algorithm, right? And with the data, with the algorithm, of course, you need to support all this processing using the sufficient computing power. Only with the sufficient computing power, you can have everything here to run in a faster way. For example, something you can run in 3 minutes. If you do not have enough computing power, you might need to have like 3 hours or maybe sometimes 3 days to complete the entire processing process. So that's why these 4 elements are very important in AI. We have to get all of them, in an accurate way, in a best way, so that we can have our AI system be constructed in the best manner as well. Okay, so this will be the 4 important elements. All right, and you will see that when we talk about AI, there's a lot of time you will hear about this term here, the machine learning, deep learning. You have heard this a lot. But the thing is that when we hear about these terms a lot, many people still don't know what are their relationship. Okay? What are their relationship? What is the difference between machine learning, deep learning? Their name, sounds very close. So what are the differences here? Okay? And is AI equivalent to machine learning or not? So maybe sometimes this can be some commonly asked questions from people. So their relationship can be very simple. You can see that AI here is a big scope. Okay, when we talk about AI, we are trying to simulate the human intent into the machine. Okay, but how? How can we perform this? there's a lot of the method we can use to perform the simulations. Machine learning is one of the technique we can use. And machine learning here is a study of algorithm. So during the machine learning process, we are trying to get the algorithm that we can use in our AI system. That is what we want to focus in the machine learning part. We are trying to find the best algorithm for our AI. But you know that for the AI system itself, algorithm is not everything. Algorithm is just a part of the AI, but you still need to have storage, you still need to have a knowledge base, you still need to rely on some other elements as well. It's not only just the algorithm stuff. So that's why machine learning is a subset of AI. Okay, machine learning is to study what kind of the algorithm is the best for our AI system. All right. And if you look into the difference between machine learning and deep learning, machine learning, as I mentioned, is a study of algorithm. If we are trying to choose the best algorithm out of all, and deep learning is actually one of the kind of algorithm we can choose for our AI. Deep learning algorithm is one of the algorithm we can choose. It's some other algorithms like, we have the knife base, we have the decision tree, we have the linear regressions. So all these are some other example of machine learning. Okay? But deep learning is one of the example algorithm. Okay? So deep learning has become very popular nowadays compared to others algorithm because you know why? It can perform even, it can perform much complex tasks compared to the other algorithm. It can learn even more complex tasks. For example, now, if let's say you want to use this AI to solve some complex tasks, to deal with something very difficult to deal with something that's very complex, you want to have an AI model that can predict well on this complex task, you might want to use the deep learning algorithm because as I mentioned, it can learn more complex patterns from the data compared to the other algorithm. So that's why deep learning now is very popular, especially when the task is getting more and more difficult. So people tend to choose deep learning algorithm to be the algorithm in their AI system. All right, so these are the relationship between AI, machine learning, and also the deep learning itself. All right. So as we can see from this, the flow here, you will see that this is the overall process of building the AI model. So when we want to build the AI model, the first thing first, as I always mention, you have to identify your scenario first. So only after you identify your scenario, then we can start with the data collection, data cleansing, all the way until we can have our model be able to deploy at the production. Okay, so this is the process of building the AI model. So if you look into each and every step in the process one by one, so the first step is to collect data. You can collect the data from multiple different sources using different techniques. So as long as until the end, you can get the sufficient data that's good in quality and quantity to train your model later. So no matter which technique you use, that doesn't matter. All right. So as what you can see from the slide, we can have multiple different methods to, to collect data, including web scraping. You can build your own data set. You can collect live data by implementing some sensors, in the target environment. So all these are the common technique that people can use to collect data. All right. And after we have collected the data, so we have to do some data cleansing. Because in the data itself, sometimes you will see some dirty data where you can have some missing value, some invalid data, or some data with the incorrect format. So all these are something you have to clean, so-called clean. So that you, until the end, before you can have the data to train the model, you have to make sure that the data quality is good. So that there's no, outlier in the data set that can confuse the model later. Okay? Because only if the good data is fed to the model, you can get a good model. Okay, if you fed the dirty data into the model, so the model will learn something bad from the data. So maybe some outlier from data, the model will learn it wrongly. So that's why to clean the data is very important. You have to make sure that the quality of data is good enough. All right. And after we have cleaned the data, so what we need to do the next is to extract and select the feature from the data set. So in the data, you will see something called as a feature. Feature is some information that we can use to describe our data. So let's say our data here is a house data. So the feature of this house data is basically the house area, the house distance from school, house color, the number of windows of the house, the number of rooms in the house. So all these are the features that will tell us more about the house data. So all these are the features, the description to our house data. So when we want to use this data to train a model, so we need the model to learn the relationship between a feature and something that we want to predict. For example, in this case here, let's say we have all this data here, the house area, the house price, the number of rooms. So we have this data set here, and we want to train this model to predict the house price based on the house feature. So as a human, what we do, sometimes if let's say people ask you to predict something, let's say people ask you to predict the house price. So before you can predict the house price, you will try to look into the feature of the house price, isn't it? You will try to look into the size of the house. We as a human, we know that if the size of the house is big, then the price of the house will be higher as well, right? If let's say the house is having a lot of room in the house, we know that this house will be somehow more expensive than those that has a lesser room. Okay, so this is the relationship that we can understand as a human. So we need this model to be able to understand the relationship between features and the house price as well. So in this case here, we have to make sure that in the data set, the features in the data set must be all relevant enough. It's like the house area. We know that in the house area and the house price is very relevant. It's very related to each other, right? The house distance from school and the house price, yeah, there are also some relationship in between. Okay, the number of room in the house and the house price, of course, the relationship is there, right? But the house color, how about the house color? Right? The house color is some feature that's not really relevant to the house price, isn't it? Because the house color can simply be changed, in just 1 day or 2 days. You can just simply track the house so that the house color can change, but it won't change the house price itself. So that's why this feature over here in the data set is something we call as the irrelevant feature. So when we want to train this model with the data set, we have to make sure that there must be all the relevant features in the data set. We will need to eliminate the feature that's not relevant to the prediction from the data set. And so this is the step here after the data cleansing. We have to select the relevant features from data set and use the data set to train the model. All right, to train a model with all those relevant features only. Okay, so only then your model will learn the relationship between the something that we're going to predict and also the features of the data. They will try to understand the relationship from there, right? So after we have cleaned the data, we have selected the features. So the next step here, yeah, of course, we have to start the training. So during the model training here, what are we doing? When we say we want to train this model, so what actually we are trying to train now? Okay, so a very simple analogy here to the model training is like, okay, you can see that there's a small boy in the slide here. So this little boy here, what he want to do is that he want to be the best basketball player in the town. He want to be the best player. So before he can be the best player, so from 0 to hero, so what he need to do is that he need to go through a lot of training. He has to go through a lot of the training. So during the training, what this little boy will do is that he will try to adjust his speed of running at different stages, at different conditions. So he has to find out the best speed of running, at different conditions. He has to figure out the right angle to shoot. He has to, make sure that the stamina is at the optimal level. He has to find out the best distance from the basket of himself, of himself from the basket, so that he can make the successful goal. So all of these are something that this little boy needs to figure out during the entire training process. So only after this little boy here can figure out the right speed, the right angle to shoot, the right distance from the basket, only if he can know, then he can be the best player in the time. So all these running speed, angle to shoot, all these are considered as the parameters that this little boy here has to adjust himself. He has to adjust so to be the best player. So same go for the model as well. So today you want to get the best model. So in the model, in the algorithm, we have the parameters as well. We have the parameters, but we don't know what is the best parameter value. So that's why during the training process, we want to find the optimal parameters to be used in the model. Okay? In a typical AI algorithms or in a typical AI model, this is what you will see as the algorithm. We will usually have the output, we will usually have the parameters, and also the input. Okay, so this is the three core elements we will have in the algorithm itself. So let's say now today we want to predict the house price based on this feature like the house area, the house distance from school, the number of rooms in the house. So we can have all of this as the input where you can see that why is the house price to be predicted. You have your house area as X number 1, you have your distance from school as X number 2, input number 2, and you have the number of rooms as your X3. Okay, so when we want to calculate the house price, you will see that we will fit these information into the algorithm. So to get the house price prediction here. But before we can get this Y value here, we have to multiply all this input value here with the parameters value, W1, W2, and W3. So this W here are the parameters in the algorithm. So only with the right parameters, we can have the right prediction. So if you see that now, if let's say we set this parameter to be some wrong value, so wrong value multiplied with your input, wrong value multiplied with your input, and wrong value multiplied with your input. So what you get ultimately is a wrong prediction. All right. So the parameters value here will affect your prediction directly. So that's why it's very important for us to figure out the right parameters value. Okay. So that's why during the model training, we are figuring out this optimal parameters. Okay. So to get the model that can give us the accurate result. All right. So of course, not every AI algorithms will look similar like the typical AI algorithms, but you can see that some common algorithms that we will use, commonly will be like this polynomial regressions, logistic regressions, softmax, or even like the deep neural networks. So all of these different algorithms here will look very different. But no matter how they look different, there will be the three elements in the algorithm. There will be the input, there will be the output, there will be the parameters as well. So these are the three core elements that will make up, every algorithms in the AI. Okay. So that's why we have to figure out the right parameters value for, no matter what kind of the algorithms we are using. So before we can do this model, before we can improve the model, we will be substituting this parameters with some value first. So to see if I use this parameter, will I get a good result or not? Okay, if I use that parameters, will I get a good result or not? So every time when we are doing this model training here, after the training, we must evaluate the model to see how good is the model prediction. We're trying to compare the prediction result and the actual value to see how much is the difference. So the difference here in between what we call as the loss value. The larger the loss, the poorer is the model. The smaller the loss, the better the model. So during the model training, we want to find the best parameter that can give us the minimum loss value. So that means that your algorithms, your model is able to predict very close to the actual value. So that is an indication of a good model, minimum loss. All right. So we will try to evaluate the model after the training. So after the evaluation, if we found out that the model is not performing well, the prediction is very far away from this actual value, it's not accurate, so we will have to do some optimization. So when we are trying to do this optimization, we'll be using some optimization algorithm called as optimizer to recalculate the parameters. Okay, so to minimize the loss. So based on the loss that we calculate from this evaluation step here, we will use this loss value, okay, to calculate something called as a gradient value. using some differentiation technique, we'll be calculating some gradient value from the loss. And from the gradient value that we can calculate, we'll be able to recalculate the new parameters value from your old parameters value. Okay, so we are trying to calculate some new parameters value, from the gradient itself. Okay, so that we can slowly adjust the parameters. We adjust it again and again and again until we can get the parameters that can give us the minimum loss. That is the optimization step itself. So the gradient value here is something that is very, it is somehow magical, because you can see that when we have a parameters value like 0.1 here, when we want to adjust it, let's say this 0.1 is not giving us a good result at the end, so we want to change it. When we want to change it, should we decrease it or should we increase it? We don't know. Okay, so the gradient will tell you the direction. It's like when you have when we have a person standing in the middle of the hill here. So this person want to go to the bottom of the hill, but he's blindfolded. He's blindfolded. So with the blindfold, he cannot see anything in front of him. So what he can do is that he can go down to the hill, follow the gradient. He follow the gradient. You know that if he can follow the steepest gradient, he will sure be able to go to the bottom of the hill. So he can go down the hill based on the steepest gradient. Slowly by slowly, he will reach the minimum point. So that is the idea of the gradient that we can calculate here. So the gradient will tell you into which direction you can find the best parameter. Okay, when you increase, yes, that direction will lead you to the best parameter. So the gradient will tell you some information. So that's why we are going to use this optimizer to calculate the gradient value. So this is what we do during the model optimization. So after we have optimized all this model, we can then deploy the model into the production. If let's say you are satisfied with the model predictions, so we can serve the model into production environment. Okay. So but with the data, with the model that we have trained, we'll put them into the repository, and we will also implement the model serving framework. When there's any client try to make a request to do some predictions, so they'll be sending this data to the model serving framework, and this framework here will call out the relevant model from the report and process the data with the model, okay, and return the result to the client in this way here. So this is like a middleman that we can use to serve the model for the prediction at the productions environment. Okay, so yeah, this will be the model deployment. All right, and so this is the overall view of our AI model in the productions. So the code is just one of the part, and of course we need to have some elements like data collections mechanism. We have to have some monitoring system to help us to monitor our applications, our productions. We have to have some serving infrastructure helping us to serve this model to the the productions, and so on. So this is the overall view of our AI deployments in the productions. All right, so since we only have like 10 minutes to go, so here I will just simply show everyone some labs here, some simple coding here to show everyone, how can we actually construct the AI model to perform the image recognition. So imagine that we have our handwriting here. So everyone's handwriting will be different, right? So like when I write a number 2, my number 2 and your number 2 will be different. So how we write the 2, how we write the number, the alphabet, will be different. So based on this different handwriting, so how can we train a model to be able to recognize which handwriting is which? Like when we fit this data here, let's say, let me show you here, another example here. Okay, so let's say we have this example here. We have these images like the image content the number 7, the image content number 1, 0, 5. So all these are the images that consist of the handwritten digit. So in this example, I'm going to show you how we can construct a model to let this model be able to differentiate, all right, this is 7, this is 1, this is 0, this is 5. Okay, so this is something called as a handwritten digit recognition. And we want to train a model to be able to recognize handwritten digits. So it's very simple. Remember this process that I've mentioned previously, starting from the data collections all the way until we can have our model deployment. So the steps we will be, that we need to go through to get this model here is like this. So at the beginning here, we will need to prepare this so-called module. We have to import the module so that this module here will help us to construct our model. So we import OS, import TensorFlow. So these are some commonly used modules, especially when we want to construct a model. So the first step is to prepare the tools. We have to prepare the tools first. So after we got all these tools here, you will see that we will need to import the data set. So this line of code here, we are importing the data set by using this module. The dataset.mnis.load_data. This is the module. It can help us to load the data from the Google repository so that we can use this data set to train a model later. So we have the training data set. We have also the testing data set. And so after we have gotten our data set by loading it with this module here, so we can then later try to check out the shape of our data. Because basically we are going to train this model with the image data. So before you can use this data to train this model, you have to understand the nature of the data first. So that's why by using this command here, we can try to look into the dimension of our data. So by printing the shape of the training data, the test data, we'll be able to understand that, there's 60,000 of the image data for the training. There's 10,000 of data for the testing. So this is the number of data. And this is the dimension of it, 28 by 28, 28 by 28. So this is the information about your data dimension and the data number. So other than this data dimension number, you might also use this kind of the module here to show the image to yourself, because maybe this is the first time you look at this data set. So you need to understand how the data looks like. So we can use this pyplot module here to show the image so that we can visualize it. We can know how to deal with it. So this is what we can do to visualize the data. So at the beginning, before we start with the model training, we have to understand the data set first. So all of this step that I showed you just now is to understand the information about your data. So you can also use this pyplot to visualize more than one images. Like for example, by using these functions here, we'll be able to display in 9 images in this way here, so that you can know, this is 5, this 1, this 1, this 0. So we are going to use these images to train a model later. So we are trying to visualize the data. All right. And other than the visualization, so let's say you have understand about your data already. So you have collected the data, you have understood your data. So the next thing is that we have to make sure that the data quality is good. Make sure that the data format is fulfilling the model requirement. So here we're trying to do some modifications on the data, like reshape the dimension of it. Because before this, when we are looking into the dimension of the data, we found out that the dimension of data is 28 by 28. It's 2-dimensional. But for the model that we're going to build later, it will actually require data to be 1 dimension. So that's why after we have understand the data, we will try to reshape the data so that it will fulfill the requirement of the model. We are doing the reshaping. So this step here, we are trying to ensure the quality of the data. We are reshaping the data. We are changing the type of it. We are trying to normalize it. So all these are the pre-processing of the data. All right. So after we have pre-processed the data, so the next step is that, we will start to construct the model. So this step here, we are defining the model by, layer by layer. So assuming that this model here is a deep neural network, we are going to construct a deep neural network with multiple layers. So we are defining the layer 1 by 1, like this is the first layer, this is the second layer, third layer. So this is how simple we can, we can define a model for the prediction. So this is to construct the model. So after we got the data and we have constructed the model, so the next step is to feed the data into the model. Okay, we are feeding this training data into the model so that we can start the model training. And we can start the model training. And so you can see that we are going to run this training for 10 times. You can define the training number according to your model size. Okay, according to some parameters, you can actually define multiple training. So as a human, like if you want to be the basketball player, you must not only just go through one training, but you have to go through multiple training. So same goal for the model as well. So we can let this model to train for 10 times, 15 times, 20 times, depends on the model. Okay, so you can see that every time the model is trained, it will be assessed, it will be calculated with its loss value. So how well is the model performance and so on after every training. Okay, so you can see that now the model performance is getting better and better after every training. So the more you train, the better will be the loss. But of course, there will be some limitation as well. It's not like, oh, all the time when you train it more, you will get the best model. It's not like that. So there will be some other story to tell as well. But you can see that after you have trained it for several times, you will see that the loss value here is getting lower. Right? It's getting lower now. All right. So because during this training process here, we are optimizing the model. Remember the model optimization that we mentioned earlier on. Okay, so the first training here will be using a set of parameters in the model. Okay? But this set of parameters has caused us to have a very high loss value. So that's why before the second training started, we will adjust the parameters in the model with the optimization algorithm that we have defined here. You see, the Aiyaaa optimizer is the optimizer that we use to recalculate the parameters. So only after we have recalculated the parameters, we'll use the new set of parameters in the second training. Okay, so after the second training with the new parameters, you can see that the loss is getting better now. Okay, the loss is getting better now after we have changed the parameters. But this is not the best yet. So that's why we'll use this algorithm here, the optimizer here, to recalculate the parameters again. Okay, again, we calculate a new set of parameters and use it in the third training. Use it in the and then try to recalculate again and use a new set of parameters in the fourth training. Recalculate all the while until we can get a very good loss value here, which is very minimum. Okay, so after the training, we can then evaluate the model for the one last time with the testing data, so to see what is the true accuracy of the model and what is the true loss of the model. Based on this result here, you can see that accuracy of the model is around 96.95%. It is around 97% of the accuracy. And the loss is just around 9. Okay, so it's very minimum in this case here. So this is the very simple walkthrough of how we can construct this simple AI model, to work for this image recognition, the handwritten digit recognition itself, or simply just image recognitions. Okay, so from the starting, when we collect the data, we clean the data, we modify the data so that it fulfills requirement. And after we modify the data, we will try to, construct a model. We got the data, we got the model. All right, we can start the training. During the training, we'll optimize the model. And after we have done with the training, we evaluate the model. So this is the entire flow of simply how we can get the AI model itself. Right. So of course, no worries. If you want this script here, I can share it with you, because I have a more detailed version of this lab itself with all this detailed information that I'm gonna share with you. So if you want, you can actually come to this Google Colab platform to try the lab on your own. You just need to simply go to the Google and type it there, Google Collaboratory. Okay, Google Collaboratory. So you search it and you will see that, okay, yeah, welcome to the Collabs. Okay, just go to the Collabs and you can start to create a new notebook in this case here. A new notebook, all right? And you can start doing the lab according to the one that I shared to you. Okay, later I can put a link in the chat itself where you can download my notebook and you can try to practice the lab according to the notebook that I shared to you. Okay, so these Google Colabs will be free of charges. You can do it anytime, you can practice it anytime. So you can make yourself familiar with how, how to construct this AI model in your free time. Okay, so basically that is what I want to show you here for the simple demo, the flow. Okay, what I want to emphasize here is actually the flow from the starting, collect data, all the way until we can evaluate the model. So what are the flow we can go through? Okay, all right, so that will be all about my lab demo over here.
All right, thanks so much, Gabby. Thanks again for the wonderful session and interesting demo as well. So as you guys can see, just with a bit of scripting and so on as well, of course, you can easily just build your own AI model. But of course, like I mentioned, we do have some exciting news to share as well. So for those who are interested to know more about this AI course, so from Infosyte as well, we are running a promotion. So we are doing a Microsoft Azure AI fundamental course as well that we are providing. That we will be having this training next month as well. Of course, you'll be instructed by Gabby as well. We will be teaching everyone on how the session will be going as well. That will be held on November 23rd. Sorry, just to get Gabby, if you could just switch to the next slide so everyone can see the prizes as well. All right, so these are the details right here. We're going to be having a class on November 23rd. So for those who are joining our session right here today, all right, everyone here is entitled to a promotion price. As you can see, we're going to be offering a $199 price here for everyone to take this Microsoft Azure AI fundamentals. All right, do take note, within this day, you're going to learn quite a lot as well, although it's just a one-day training. You're going to learn how AI works as well, what are things you need to take into consideration. It's just a simple course as well, as shown from what Gabby has been taught. All right, so we're going into more details as well, and you'll be able to create your own AI services here. For example, with a natural language processing, you'll be able to deploy your own NLP workloads on Azure as well. Okay, so for those who are interested, who are in this session right now, whether you're from Zoom or from Facebook, anywhere that you're watching this from, do drop us as an email at sales@infosyte.com and just let us know, hi there, I'm interested to learn more about Microsoft Azure AI Fundamentals certification or training. Just do let us know. Of course, our sales personnel will get back to you as well. Okay, and as Gabby has shown in the next slide, you will be able to get all the details from Infosyte as well, just from one link, as I'll be pasting it in the chat as well. Just a simple link tree for Infosyte. Here you get to find all our how to contact our sales personnel, find our LinkedIn page, our Facebook page as well. Do follow our Facebook page, as we do keep ourselves updated, and you'll be able to find out what we have next for our November live webinar session as well. All right, so do contact us if you require any other information, as the email, like I just repeat here, sales@infosyte.com, or just scan this QR code or follow the link. You'll be able to get all our details, our social media accounts as well, our platform, everything will be shown here as well. All right, so that's it for our session. Thanks again, once again, everyone who's attending this session as well. Just a gentle reminder to the winners of the cover session, kindly do drop us your details as being sent by Jonis as well. Just fill out the details and we'll be contacting you shortly to provide you with your prizes as well. All right, so thank you so much, everyone. Just one last item, kindly fill out the survey form as usual. The survey form link has been provided in the chat as well. Kindly do fill it up and let us know what are your opinions. How do you think about the entire live webinar as well? Or is there any other topic you're looking forward to next time? All right, so that's it from us. Thanks a lot once again, Gabby, and thanks a lot as well for everyone for your time and participation here today. Hopefully you guys enjoy the session, and looking forward to see you all again next month for our next live webinar session. All right, thanks everyone. Enjoy the rest of your day. Bye.
Infosyte has been one of the top ICT services and training provider companies in Malaysia. Infosyte office is located at Sertia Walk in Puchong. Our location is easily accessible and strategically located within a walking distance of LRT and bus stations. Our vision is to inspire excellence through our sworn commitment to quality, innovation, and efficiency. We ensure excellence and experience in our trainers to strive for our goal of providing only the highest quality of services to our students. We provide a wide variety of training programs which include technical training and soft skills training, both indoor and outdoor training. Our spacious, comfortable, and affordable training rooms are available for rental with high-speed internet. With our experiences in delivering ICT expertise to thousands of clients all over the world. Infosyte works with partners such as Huawei, Microsoft, Veeam, Linux Professional Institute, and CompTIA. We have many happy and satisfied customers and students all around the world, places like Canada, Poland, Australia, South Africa, Nigeria, Japan, Singapore, Norway, Hong Kong, Tunisia, Botswana, Kenya, Thailand, Indonesia, and many more. Infosyte, your trusted professional training experts.